and gate 2 remains in the complementation condition q which is equal to 0. This is a hold condition. So we have 4 condition, no? 0, 0, 0, 1, 1, 0, 1, 1. So in that 0, 0 means the hold condition. So next is OR latch operation, where S is equal to 1 and R2 is equal to 0. So the same circuit diagram and truth table operation. So gate 1 into complement condition q which is equal to 1, and gate 2 is always 0 condition q bar which is equal to 0. So there is a set condition. So in RS latch operation, so S which is equal to 1 and R which is equal to 1 means, so gate 1 in always 0 condition q bar which is equal to 0, and gate 2 is always 0 condition q bar which is equal to 0 and q will be 1. So this is a illegal condition. And RS latch state transition table. A state transition table is an alternative way of viewing its operation. Here we have a 3 input QSR, and 0 will be a clock state, and 1 will be a clock will be 1, 0 will be clock will be 0, and S are the same operation 0, 0, 0, 1, 1, 0, 1, 1. So the next, if it is clock 1, 0, 0, 0, 1, 1, 0, 1, 1. And comment 0, 0 means hold state, 1 means reset state, set state, 0, 1, 1 illegal state. Similarly, hold state, reset state, set state, illegal state for q which is equal to 1 also. A transition table can also be expressed in form of a state diagram. So here RS latch state diagram. A state diagram in this case has two states, that is q which is equal to 0 and q which is equal to 1. The state diagram shows the input conditions required to transition between states. In this case we see that there are 4 possible transition. We'll consider them in turn. So RS latch state diagram, QSR and Q will be 0, and for that condition we have a 4 combination 0, 0, 0, 1, 1, 0, 1, 1. Similarly Q will be 1 means we have 4 combination 0, 0, 0, 1, 1, 0, 1, 1. The Q bar will be 0, 0, 1, 0, 1, 0, 1, 0. The comment is hold reset set illegal, and similarly hold reset set illegal. So in state diagram explanation, q which is equal to 0, q bar which is equal to 0. From the table we can see s into r bar plus s into r plus s into r which is equal to s bar into r bar plus r bar r plus r bar which is equal to 1. So s into r is equal to s bar plus s into r which is equal to s plus s bar which is equal to 1, s bar plus r which is equal to s bar plus r. So this will be the expression, and q which is equal to 1, q bar will be 1 from the table we can see. So this expression. So this is RH latch state diagram. Here also QSR, the Q will be a 0 state. We have a 4 combination 0, 0, 0, 1, 1, 0, 1, 1. And similarly Q will be 1 means we have 4 combination 0, 0, 0, 1, 1, 0, 1, 1. And Q bar will be 0, 0, 1, 0, 1, 0, 1, 0. Here hold reset. So just a reverse of the operation. And Q bar will hold reset set illegal, hold reset set illegal. The previous slide in the case hold set reset illegal, here hold reset set illegal. So in that q which is equal to 1, q bar which is equal to 0, from the table we can see s into r bar which is equal to plus s plus S into R which is equal to R into S plus S bar which is equal to R. So here Q which is equal to 0, Q bar which is equal to 1. From the table we can write S into R. And this slide shows the latch state diagram. So which gives the following state diagram. S plus R, here we have a Q which is equal to 0 and Q which is equal to 1, and S plus R. So it will be given to the S into R. The previous will be come back to the R. So it will be result will be R. A similar diagram can be constructed for the Q bar output also. We'll see the later that state diagram are also useful tool for designing a sequential system. And so this slide shows the clocks and the synchronous circuits. For this, the RS latch we have just described, we can see that the output state changes occur directly in response to changes in the inputs. This is called asynchronous operation. So however, virtually the sequential circuits currently employ the notation of synchronous operation, that is output of sequential circuits is constrained to change only at a time specified by the global enabling signal. So this signal is generally known as a system clock. And the clocks and the synchronous circuit, the clock, what is it and what is for? Typically it is a square wave signal at a particular frequency. It imposes order on the state changes, allows lots of states to appear to update simultaneously. And how can we modify a synchronous circuit to act synchronously, that is in synchronism with clock signal? And the transparent D latch. We have modified the RS latch such that its output state only permitted to change when a valid enabled signal, which could be the system clock, is present. So this is achieved by introducing a couple of AND gates in cascade with the RS inputs, so that are controlled by additional input known as an enable input. And this slide shows the transparent D latch. And in this case, here we have a 2 AND gate and 2 NOR gate, 1 inverter. The D input is given to the first AND gate. That inverter D bar will be given to the R, and which will be given to the AND gate, and the AND gate output will be given to the input of the NOR gate, and which will be represented by R and S, and that will be fed back to the output fed back to the NOR gate respectively, Q and Q bar. And this is symbol diagram. D, Q and enable. The enable is enable signal. If it is 1 means it will be enabled, if it is 0 means that it will be disabled. So that is the basic operation of transparent D latch. And see from the AND truth table, if one blank of the input says and alpha is 0, the output is always 0. So output follows B, input of A is 1, and the complement of functions ensures and that R and S can never be 1 at the same time. That will be illegal, avoided. And truth table is AND operation is nothing but multiplication, and A, B are the inputs and Y will be the output, means 0 0 and 4. We have a 4 combination 0 0 0 1 1 0 1 1, and if any one of the input is 0, the output will be 0. So in which case the output will be 1, means both the inputs are 1 will be, and output will be 0. So this is a condition for AND truth table. And so this latch, D latch is nothing but delay latch, transparent D latch. Here we have a 2 AND gate and 1 NOT gate. NOT gate is nothing but inverter, and 2 NOR gate. The NOR gate operation will be the same, which will be connected back to the AND gate and inverter gate, that is NOT gate. And Q and Q bar will be the same, it is RS slash. So that RS slash will be given to the combined together to give a single input is nothing but D latch.